It has become very nice now that from Howrah to Guwahati, you can go in the what do you call Vande Bharat sleeper train.
Ah,
This is the first sleeper train, and
very nice.
it will take only 15 hours.
Oh,
पहले
it is
जो
that
25-30
Howrah to
घंटा
itna dur
हाव-
hai. That's
हावड़ा
like,
to Guwahati.
yeah. So I thought that Assam is next door to you guys from Bengal.
No, 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 no. It's a huge distance. Earlier, it used to take about 24 hours, more than that.
Oh, yeah. It was.
Uh,
It
ju-
was. His style is the same. He used to give the similar speech in Bihar election. I was watching that speech today, early morning. Yeah.
just
He
in front
started
of
in
my
Bihar
house.
like Maithili, Bhojpuri, and then you know the same few things.
Yeah.
Hopefully, what is the mood there?
Mood in Kolkata?
Yeah.
Good afternoon, sir.
Abhi, now one sees, difficult to say, but
It's too early, right? It's too early to
it
say.
is too early to say.
All right, let's get back to science. I think only Aryan is there. So your favorite student is here, and Aryan, your favorite teacher is here. So let's have some discussion.
Yes, sir.
I'll go and make the coffee in the meantime for myself.
No, no, while making coffee, you have to hear what we are speaking, you see. Is it very cold in New Jersey?
Please unmute, sir.
Unmute कीजिए.
Yes, sir. Please unmute, sir. Amarnath, sir, your sound is not. Please unmute, sir.
Saying that other Amarnath has a connection problem, looks like, right?
Yes, sir. We'll continue, I think, after a few minutes.
Just in front of my house is St. Xavier's University, and they are having musical programs almost from morning 8 to night 12.
Oh, okay.
You might be able to hear, I think all celebrities are coming there. हम लोग घर में बैठे हैं.
So I have a
ठंडे.
question for the young students that we just celebrated Makar Sankrant, right? And there is a theory that it is a very scientific thing there. What something happens, Earth rotation, and then we celebrate that Uttarayan or whatever. I think Uttarayan, that's what we call it. So, can somebody explain what is that Uttarayan? What is happening in the Earth rotation? And very interestingly, Indian calendar and Western calendar match this day together. Pretty much, it stays like now it is 14, but I heard that this will be for several years, and then probably it will move to either for 15th of January,
Yes, sir.
right? So if that is something which, if you guys can explain what happens in the solar system, why, and then also we think that our days starts becoming bigger, right? In this
Yes, sir.
period, next 6 months, I guess, right? Next six
Yes.
months, yeah. So that will be nice. Let some other students also come, and then maybe you guys can do some discussion on that topic.
Yes, sir.
That will be nice.
Yes, sir. So, sir, I think so. This Makar Sankranti, in this, what happens that the Earth goes to a new constellation. I think so. It is called the Makar, and uh, I think so. That marks the beginning of longer days. Yes.
So one Muslim scholar was questioning that it happened something in the December, like 25th or 26th of December. Then why do we do it on 14th of January? That was his question.
Okay, sir.
That thing change which you are saying is celestial change that is happening sometime in December, right? 23rd December or 26th, something like that. So, but then we celebrate on January 14th. And why is that?
Mm,
That's supplementary question. That is a more cultural question, not the scientific one. But is it the change is happening? What is exactly the date when the change happens? Is it January or it is December 23rd or 24th, something like that? Can you find out?
My answer is 23rd December.
Yeah. Okay. So
So
some
23rd December. So now this sun is
closer.
um, on 23rd March, 22nd March, I think 22nd March, the sun will come over the equator. So now the journey will start from from the northernmost part. Sun will now go towards the. It has started on 21st December. It's not 21st, not 21st. Okay, whatever it is, but it is
Yeah.
December. Yeah,
Yeah.
December is the turnover time date.
Yeah.
Now, Makar Sankranti is a very interesting in the sense uh, what um, what Aryan has said is correct. Is that as per the Hindu calendar, no, it is going into the Makar. This thing Rashi में जा रहे
Right.
हैं.
Right.
But इसका जो significance सबसे interesting है कि on this date, see the Indian calendar goes by the moon and the sun.
Uh,
Both are both play a role
mm,
in the sense that moon, makes a rotation in 29 days.
mm,
So, so, and now the earth rotates around the sun in 365 days.
mm,
तो यहाँ पर आकर के इसको मैच किया जाता है, इसीलिए तो जो बीच बीच में जो होता है ना, एक्स्ट्रा मंथ हो जाता है वगैरह, सो
mhm,
मैच
mhm.
करने के लिए.
Right.
तो सो एवरी ईयर दिस मैचिंग इज डन, यू नो.
Uh-huh.
And Makar Sankranti ko it is just same as in Gregorian calendar as so in Hindu calendar.
Mm,
Where again it starts again because it goes by the Indian calendar will go by the moon and the Gregorian calendar will go by the sun. So mismatch will start and then it makes correction somewhere. Indian calendars make it. Because all Indian calendars they try to make it 365 days at the end of the year.
mm.
So this
Okay.
is what my understanding is.
So I thought that this extra Malay Mass that doesn't happen
Yeah,
every.
yeah. That Malay Mas is that trying to match it,
Yeah, yeah,
those
but that
extra
doesn't happen
things.
every year. That is only some time I heard. It's not like you get it every year, that one. So the time which you are saying adjustment happen, it happens every few years. That is when we get extra mass.
Yeah, but they do the matching. They do it. The matching they do it. No. So you mean to say it's every 4 years this Malay Mas takes place? I am
Something
not a
like
good.
that.
I don't have a good knowledge of the Indian
Yeah.
calendar system.
If I remember, that is not every year, but I don't know exactly if it is every 4 year or it maybe depending on what it is. But it's not
That's a leap year something 29th
year is
February
4 years.
something, one day
4 years.
only, one
Leap
day
year.
only. Yes,
Yeah.
sir,
But
one
our
day.
calendar, the Malmas is not every year. Otherwise, we'll have 13 months, right? So that happens like I think every this adjustment. You are right. That is the adjustment of the time to match with the other calendar. Or I don't know if we already had this one before also without matching with the Western calendar. Probably our previous sages, astrophysicists were doing it in the Indian system, Bikram Sambat and all that, that they knew that we have to have the 365 days, so how to adjust it. So it was in practice. But that extra month gets added only that error month, we call it, right? Error month that gets added when necessary, when it becomes almost like a close to a month, I think.
Yes, this is basically adjustment that no, every year you see the difference comes how much? 29 into 12 is how much? 290 and plus 58. So 348. So now the Indian calendars they have this 29 days because it goes by the moon actually.
Yeah,
It goes by the moon. So
right.
you have got 348, but actually it should be 365. So you have to make some adjustments every year. I myself do not know much that how the adjustment
I
is
think,
done.
yeah, Om Prakash
Yeah,
is the expert on this, so maybe
yeah,
he
yeah. Om
can.
Prakash ji, where is he? Where? Yeah, he knows these things.
Yeah.
But
Oh, yeah.
then Indian calendars, no, the like say Mithila calendar has got a little bit different. So usually, and like the calendar followed in West Bengal is a little bit different. And in South also it is a little bit different. Means the way the adjustment etc. they are done, something is it is too complicated for me. Let me let
Yeah.
me admit.
Yeah. Okay.
How to adjust the moon and the sun together?
I see two more students have joined in the meantime. Hi. Can you please introduce Gautam Roy and Shreya?
Sir, my name is Earth.
Yeah,
Why you are
Gautami. Gautami is Earth.
why is that? Why you have this Gautam now?
Sir, I had to join from another account due to some problem.
Oh,
Oh,
okay. Okay.
and then we have
Good.
Shreya.
Yes, sir. Good evening, sir.
Yeah, Shreya, you know about the Indian calendar and the Gregorian calendar.
Yes, sir. I know, but not much.
Okay. So what is the difference between the two? I only know Gregorian calendar. So sad. I should have studied it properly. But then there are so different systems, no? In Bengal, when Meghnad Saha came, so Nehru gave Meghnad Saha that whatever the abnormal things are there in our calendar, you correct it. So Meghnad Saha introduced many corrections actually, and Indian government follows the one which is the corrected one. So there is a difference between the calendar follow which was introduced by Meghnad Saha here, which is followed by the Indian government, and then difference in Banaras calendar and the Mithila calendar. And there are so many different calendars are there in the country. I always get confused. They do adjustments. कई बार दिन जो है एक दिन का से कम हो जाता है, कई बार एक दिन से अधिक हो जाता है. They do complicated way of adjustment to make it on 15th of January match everything. So बीच में भटक जाते हैं, फिर सही समय पर आ जाते हैं, फिर again the whole thing starts. And big changes are done by the Malay Mas. There is an extra month, one is added once. I'm not good at it actually. Aryan, you know about it?
No,
Hello?
sir. No, sir.
Adjustments are done in different ways in different calendars.
Yes, sir. Saksham has joined, sir.
System is,
Sir, Saksham has joined.
oh, yes. Hello, Saksham.
Yes, sir.
Do you know about Indian calendar?
What do you mean to say about?
No, we were discussing that what is the difference between Gregorian calendar and the Indian calendar. Anyway, I think maybe let us all study and come back next time. So let's go back to the now the question session. Who wants to ask a question?
Yes, sir.
Archana, Saksham, you want, Aryan, you want to ask?
Yes, sir.
Yeah, what is the question?
Sir, how are the distances between the stars measured?
Distances between the stars, how they are measured.
By the
No,
light,
by
it
the
depends. It depends on how many years does the light has taken from to travel. Suppose we are seeing Proxima Centauri star system and we don't know the distance from Proxima Centauri to Earth. So we see its light is how much old. If it is 4 years old, that means the light has taken 4 years to reach Earth. That means it is 4 light years away.
So, sir, how do we actually know how much time has passed away from the start?
By its graph,
What?
by its graph and photonic intensity.
no, Saksham. So what Aryan is asking that suppose you want to make distance you want to measure, then you want to measure in light years. Of course, the light years is a measure of unit of distance only. So how much time it has taken? How will we know that how much time it has taken? That is what he's asking.
Mm, I think, sir, by the parallax for nearby stars, like the
Yeah.
Cepheid intervals and redshift Doppler effect, etc.
Well, the simple answer, yeah. So do you know what is parallax, Saksham?
Yes, sir.
What is parallax?
Mm,
Okay.
sir, I don't
Yeah,
know
yeah.
very much about it. I only know that it is the apparent position of shift and is used to measure the distances between the stars.
Yeah. No, but the one thing question I am asking, how do we measure the distance of any star from Earth? Well, the very simple technique is that you observe the star. If the star is very far away, so you observe the star, let us say, from the opposite ends of the Earth's revolution. Suppose you observe the star, what is the angle? In let us say June 23. Then after 6 months, you observe the Earth will go on the opposite side. From there again you observe that star. And this angle which it will be there, no, from that you know the distance from the two positions, you know the distance. So and you know the angles. So from trigonometry, you can find what is the distance to the star. This is one most prevalent way of finding the distance to the stars. There are many. When it is done, it takes many sophistications, but this is the basic principle which it follows. Yes, yes, Saksham.
And sir, I am having one more question that how do Do we identify stars which are millions of light years away?
No,
Like
that's because
IPTF 14 HLS, also known as zombie star, which is 50 billion light years away.
identify means our telescopes have become so powerful nowadays. You know, so
But
it is a
sir, they can. But sir, they can even be the galaxies because galaxies also look very similar to distant stars.
no, galaxies have many stars, and some of them are bright, some of them are not bright. So mostly the ones which we are able to capture the light, then we measure the distance to them. As a matter of fact, to tell you, the last year I went to one of the observatory, and they were trying to see the one double star in an Orion galaxy, and they showed us how the double star is there. I asked them, how do you know it is a double star? Because they found that today, if I see like this, the next day, suddenly in few days, it changes its position, all going around itself. And they were able to spot double star in that, in the using the telescope. It was a 48-inch telescope. Very interesting. Yeah, but this is quite a very sophisticated subject, by the way. Actually, earlier, but the basic principles are this one only, that you have to know the angles, you know the distance, the distance between the two earth positions. So you are able to construct a triangle, and then you can measure the what is the perpendicular. So basically what it is.
Oh, so
But
basically,
the
you take the
yes,
two stars. You take the two stars,
yes,
and then you the two stars, and then Earth. This is how it is. So that's how they form a triangle. That's what you're saying.
yeah. Well, actually, you're showing me there. Okay.
Yeah. So let's. I mean, I'm showing you
The
something else.
triangle is basically is getting formed by the Earth is on the one side, and after 6 months it will be on the opposite side.
Yeah, but
So
Earth is my point is that you need for a triangle three different apex points, and one is Earth. That's what you are saying, and the two are the different stars.
no,
But
no, no. See, we are looking at one particular star, but we are
yeah,
looking at one particular star from one position. Then, and from 6 months after that, the Earth will be on the opposite side of the sun. So we know this distance between these two positions. Means
oh,
the distance when the Earth is, let us say, on June 20th, and then December 20th, means after 6 months, where it will be, we know this distance of the Earth.
okay,
And then we know the observation angle. So these angles, which is from the two positions we know. So we
okay,
can
okay.
just drop a perpendicular, that perpendicular, so we can find out calculate the perpendicular.
Wherever those
So,
two points intersect, actually, you don't have to
yeah,
draw a
yeah,
perpendicular.
yeah, yeah, yes,
Intersection of two rays from the two parts
yeah,
of the Earth.
yeah.
Okay. But
The-
my question is that these 2 points where you are observing from the Earth, they are always going to be the same
Oh,
because
well, no, actually, compared,
I
because
mean,
since we are looking at
not
a star,
not not exactly, but what I mean in general sense, because Earth's diameter is pretty much more or less fixed. So it doesn't matter if you take a picture from one point or the other. The distance between the 2 points is always going to be the same, right? Most likely.
yeah, it will be same. It will be same. That is the assumption.
Yeah.
There won't be much
So
difference
then
in that
okay, so that distance is fixed, then only then is now the two angles. That
angle.
is, yeah.
So it was the measurement of the angle which the telescopes have given us this, what
Okay,
Means
so
a benefit.
telescope. Okay, so telescope gives you the angle. That's what you are
Right.
saying. That is, yeah.
Yes, yes, yes. From the two positions.
Yeah,
So you know
yeah.
the angle.
So did you guys get it? What is he saying? Now it is clear.
But by the way, this is a subject in itself. There are books and books written on this one, and it's
Yeah.
quite an interesting thing, by the way.
Okay. So let me see if I can draw a picture on PowerPoint, something to show the kids. I want them to get it because I also didn't know about it, that how exactly they measure. Is there anything other than the Hubble telescope, or Hubble is still the latest?
No, after the Hubble, Hubble is the level, but they are making another big one. No, I think.
Yes,
And
sir.
on the Earth, you have a lot of big telescopes are there.
like the James Webb Space Telescope
Yes, that
and
is
the
also
TESS
there.
Telescope, Gaia Telescope,
Yes.
etc. Nicer also.
On the Earth also you have yeah, that is what I was telling that
Yes,
last.
sir. On the Earth, we also have large telescopes like the famous Event Horizon Telescope and the, you can say that, ALMA Telescope.
Yeah, yeah,
Nice.
so many telescopes are there. So the no, what I was saying that I was just two years back, I think I went to see in California itself 48-inch telescope, and they were able to show me a star in the Orion galaxy, a double star. They showed me. That means
Nice.
the telescopes have become so powerful. But then that is a 48-inch only. There are 200-inch telescopes are there. Then there are other inputs are there. Other inputs that is it emits gamma rays and all those things. So you have radio telescopes.
Hmm.
But the basic principle is this one.
Sir, I have a question that why does the mirror of the telescope always depends on the distance of the telescope can we see?
No, mirror, the size of the mirror gives that the more light can be collected. You see, a star very far away sends very feeble light. So bigger the mirror, more the light is collected. So the picture is much better, you see. That is why you need bigger and bigger telescope. The Galileo, when he made it, he could see for the first time the moons of the Jupiter, which we were never seen by human beings.
Okay, sir. So suppose we
And
have
that was a 12-inch only. That was 12-inch telescope. Yeah, you're asking something? Hello?
Yes, Saksham.
yes, yes, sir. I am having one question that you have just told that the mirror of the telescope always depends on the distance of the telescope covered by it. So I have it. I
No,
have
no,
a
not
telescope.
distance. The mirror, more bigger the mirror size, the bigger the mirror size, more light is collected from the star. So you can see them. So if the mirror size is small, then very little light is collected.
And we can see far away also if the mirror is larger.
Yeah, yeah, sure. Yes. Larger the mirror, better it is. And then you have a Hubble telescope that goes because a lot of light is gets absorbed in the atmosphere. So if you send the telescope in the space, then you can see still better.
Yes, Shreya, you have any question?
Yes, sir, I have question.
Yeah, please go ahead.
So my question is that why do seawater release salt or have salt in them, but rivers do not?
What is that? Can you repeat it? There was a vibration was there in the sound. What was that?
The question is why
Hmm.
salt is present in seawater but not in rivers?
Uh, oh my God, this is a very tough question, by the way. No, but seawater does have something, but of course, they
Sir,
all
can
the
I, sir, can I
someone
do
wants.
some guesses?
Yeah, please, please.
So, sir, what happens that when the river starts its prevalence, or you can say its movement, then the river is purely formed from the glaciers of the mountains. So, as it
Yes.
travels, it collects soils and the other salty materials from the land, making it saltier as it travels. So, when it finally pours down to the sea, then the salts collected from the land plus the salts collected in the sands and lands beneath the ocean makes the sea water very much salty.
Yeah, I would like to accept this answer, but I don't know. There might be something in-depth question. Answer might be there. Are you satisfied, Shreya?
Yes, I am satisfied, but yes, I am satisfied with this question.
Somehow I am partially satisfied, but I have no alternative answer in my mind right now. Anybody has any other answer?
Thank you, sir.
Malikji,
Sir,
So
now you can explain.
sir,
I
I
draw a picture for kids.
yes, yes, please go ahead. Saksham,
yes,
no?
yes, sir. I was. Can I continue to my previous question? I have not completed it yet
Yeah,
about the
yeah.
telescopes. Yes, sir. So suppose if I am having a smaller telescope with a smaller mirror, can I give it its photo right now? Hello,
What
sir.
is, sorry, please, can you repeat the question? There is a voice, something echoing is coming a little bit. Please repeat the question.
Sir, if I am having a smaller telescope with a smaller mirror, then can we see the stars and a distant object? Can I show the figure of it once
Can I show the figure?
He wants to
of my question once in
Yeah,
this? Okay, sir.
I'll. You can start putting together. I'll.
Okay, sir. So suppose if this is a telescope, then this area is the mirror. So how far can I see from this mirror? Can I see it beyond our solar system?
Of course, of course. No, I don't know how many inches of this is there.
Oh,
How
very
many
nice.
inches?
Oh,
What is the size of the mirror?
Sir, I think so. The size of the mirror may be 5 centimeters to 10 centimeters, etc.
Oh, then there is not much more chance. It's certainly better than naked eye. So,
yes,
yeah,
yes.
but you
So,
can't distinguish the stars.
yes, sir. Sir, I also have a bigger telescope than this, but it is not like very good. I can see the moon clearly from the telescope.
Right. So what is the size of the your this
Sir,
one,
I can
Aryan?
Sir, I don't remember. I think so 5 to 10. It's between 5 to 10 inches.
Sir, I can only see the moon from this telescope. So can I see even further distances from this telescope?
No, no, you can see, but question is that how to distinguish them. You will be seeing. See, you will be seeing, but what you're we are seeing telescopes because we want to identify them, separate them. Rather than you see a galaxy will appear like a spot, but a
Yes.
galaxy has got a million stars. So you
So
want to
sir,
differentiate them. So that you can't do with a 4 or 5 inch telescopes. You have to have much bigger telescopes.
I think so. The diameter of the mirror might be 20 centimeter, but if it is really 20 centimeter, then how far the distance I can see it from?
We, sir, I have also tried it with other stars, but they just appear like a dot.
Yeah, it will appear like a dot. No, how far? No, question is not that. See, suppose there is a star which is emitting intense light. So even if it is more distance, you will be able to see it. Question is that we want to distinguish them. Instead of a collection of stars appearing as a dot, we want to distinguish them. Either mirror or the
The solar system with this telescope.
nahin, just see that even without the telescope, I am able to see beyond the solar system. But what am I able to see? Only some 2000 stars. On any good night, you can't see more than 2000 stars. And most of the stars which you are seeing they are of Milky Way only, not other galaxies. But if you have bigger and bigger telescope, you will see the stars of the Andromeda also, which is our nearest galaxy that we have.
Yes, sir. So
Then,
my question is that can I see the different planets of our solar system from this telescope, like Neptune or even distant dwarf
yeah,
planets
so it
like
is.
Pluto, etc.?
Yeah, yeah, you can. If you are saying it is 20 centimeter, you should be able to see. 20 centimeters means it is 8 inches. Yeah, you should be able to see. That is what Galileo made first. You can see the planets, you can see the moons of the planet. At least the 2 to 3 moons you can see on a clear night. Maybe in February you are going to see the sky is going to be clear and you will be able to see many planets in a line in February. Look in the newspaper, I think the date is given on which date you'll be able to see. You'll be able to see. Yes.
No, sir. It was mine.
Okay. Okay. So next. Yeah, try it. Telescope watching is a very nice thing, and read a book also. How to locate a planet or a star system. There are very good books are there.
Sir, I am having one more question. That how can we see these planets from the telescope, which I showed you some minutes ago?
No, how can you see means, sorry, I'm not getting how you have to use the telescope is just what? Telescope is just it collects the light from the stars or the planets and focuses them, you see. So with the focus, it focuses them. Now, more the light collected, better is the picture. Less the
Yes,
light
sir.
collected, blur is the picture. That is what it is.
Yes,
So
sir.
some people, they attach a camera in the telescope, and they observe it for 3-4 days, say 3-4 hours. They collect the light.
So, sir, what is the process? I have also tried to see planets on my telescope many times, but I was unable to see. So, how can I see it from it?
No, planets you can see. You see just a dot-like structure. You will see with your naked eye itself. But if you want to see something like, say, the Saturn ring or the moons of the Jupiter, then you have to focus it and see it. And with a telescope size, say about 8 to 10 inches is good enough to see them. At least the moons of the Jupiter.
Sir, whenever I have pointed my telescope towards these planets, I was unable to see them clearly.
Oh, oh, that could be a telescope problem. Telescope, but you won't clearly miss. You will see a little bit bigger size. That's it. Why don't you try it when the sky is very clear? You try, only then you will know it, whether there is a problem with your telescope.
So Malikji, here is the picture of the what you were explaining. Maybe you can now explain one more time to them about how it works, telescope works to measure the distance. Like the circle is the Earth, our planet, and then from there they are measuring the far off distance, right? If you see the top right corner, you guys can see that one, right?
Yeah. The right corner, you see, this is what I was telling.
Yeah.
The right hand side, which you see, so there are the two ends, and then they are seeing it. But actually, I'm using my mobile, so it is appearing just like a small dot.
Okay. Yeah.
No, it is much better than a small dot, but I can see the circle and I can see those lines
There is,
drawn.
I
So
mean,
this is what I was telling. This is just I was
yeah.
explaining this only.
You really have to understand the mirrors, those concave and convex mirrors, and their focal length, how it works, are in play. And they use, I think, 2 or 3 different mirrors to kind of collect the lights. It's not like there are different optics. That is the area. All these telescope makers, they have to be expert on optics. That is a complete new, a separate field for physics, which is used in many areas like telescope making, as well as we use in semiconductor, in lithography also a lot. Like there is a company TSMC, who makes all this lithographic equipment for computer imaging, they also use. So you have to understand the physics behind the lenses. So I would encourage you guys to review the light section of your physics book, or get a books on optics itself, or at least search for the optics on the YouTube, and it will tell you. Unless you understand the physics of the lenses, you will not be really able to grasp this measurement scheme.
So Aryan was wanted to ask you a question. Aryan, yes, go ahead.
No, sir, I had a different question.
Okay. No,
So,
so
sir,
are we through with the telescopes?
yes.
Yes. So let's see the next question.
So, sir, I had a question. Sir, I did not understand the Bell's theorem. I tried understanding it, but I couldn't.
You're talking about statistics Bell's theorem?
No, he's talking about the quantum mechanics Bell's theorem.
Oh,
Yeah. 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 So Aryan, Bell's theorem, no, I also won't be able to guide you very much. It's really difficult actually, but I won't be able to guide you. But then if you give me some time, then I will just go through it once again. But it's a difficult one actually.
So, sir, I had one more question. So,
Yeah.
sir, we know that whenever there is a force applied, there is another opposite force acting on that. So, sir, when we are walking, we are going in that particular direction. So, why we are not forcing the opposite forces?
What did you say? When there is a force applied, then there is an opposite force.
Yes, sir.
Where from? For example, can you tell me an example? What is it that you have in mind?
Sir, I think so. When you push something,
Then it pushes you back.
yes, sir.
So when you're talking about the third law of the Newton, is it?
Yes, sir.
So now rephrase your question once again.
So, sir, when we walk, why
Hmm.
don't we experience the opposite forces?
I can say something.
Yeah, please,
Oh,
please.
yeah, there is
Yeah,
another thing.
Udayji, yes, please.
Yeah. So
Perfect timing. Perfect timing. Okay.
no, actually the thing is we ignore something called friction
Oh,
and we ignore something called weight. So whenever we are running or walking, your feet is exerting some force on the ground.
okay, sir.
So you're pushing your whenever you're trying to run or something, you're pushing the ground below to move forward.
Okay, sir.
I, Aryan, I'll give, yeah, that is what Udayji has said is some interesting. I'll add something to it. What is there is that, let us say, suppose a moon is traveling around the earth. So if I'm sitting on the moon, and I have a knowledge that there is a gravitational force. But when I'm sitting on the moon, to explain, I won't feel anything. So you'll feel that there is a gravitational force. And then there is a imaginary centrifugal force is there, just to balance it. See, a man sitting on the moon, when it is going around the earth, he will explain his motion that there is a gravitational force which the earth is attracting me, but I'm not falling on the earth. I'm still rotating. So he would say that there is one centrifugal force, which is an imaginary force. There are only four forces. Centrifugal force is not a part of it. So there is a centrifugal force. But the man who is sitting on the earth, he will see, he doesn't need a centrifugal force. He will just say there is a gravitational force and the moon is just getting accelerated towards the earth, but the distance covered is such that it still remains in a circular orbit. Am I able to make it clear? So it is basically a question of the frame of reference. In which frame of reference you are talking about which force? There are only four forces. All other forces are imaginary.
Okay, sir.
Yeah. And what Udayji said, where does the frictional force come into it? The frictional force again comes, it is none of the four forces, it is another force which is a collective force. It's something by the one object, there is an impediment from another object because of the contact problem. So there is that is not an extra force. That is not a natural force. The natural forces are only four forces. But from the frame of reference, you need to have another. Just I said, suppose you are going. Yeah, the same thing. I won't repeat it. I think I would like you to think about it. This is very interesting, actually.
Okay, sir.
Udayji, am I correct?
What I interpreted his question was that whenever we are walking, why don't we face opposite force. Is my understanding correct? Aryan?
Yes, sir.
Yeah. So what I was trying to say is when you are trying to walk, you're pushing your ground down and backwards, and the ground is pushing you upwards and forward,
Upward.
and that's why
Right.
you're moving. So there is opposite force which is happening. You are not experience or feeling it, but your movement is happening because of opposite force acting against the force that you are applying on the ground. You're pushing the ground down, the ground is pushing you up. You're pushing the ground backwards, and the ground is pushing you forward. That's the opposite force. That's so I literally gave him a definition of what he was asking, what I understood.
Yeah, very correct. That is.
I see one question. Who has that question?
Saksham. Yes, Saksham.
But
Yes, sir. I am having one question that at which point electrostatic force is used?
At which point?
Yes, sir. Suppose we use a strong nuclear force to keep the atoms together and make them stable. So, at which point electrostatic force is used?
So let us say in case of atom only, there is proton, which is electrostatic forces will only be there between the charged particles. So in the atom, you have got the proton, which is positively charged, and there are electrons around it, so which are negatively charged. So there is going to be a electrostatic force between them. Is that sufficient, or you are not satisfied?
Sir, I am not satisfied.
Yeah. So your question is, where do we feel electrostatic forces? So wherever there are charges, there will be electrostatic force between them. Wherever there are charges.
So, sir, if we are near electrical appliances or near electrical charges, then we can feel electrostatic force.
It will be there's yes. So where you're near electrical appliances, but you'll be surprised they neutralize actually. But wherever they don't neutralize, you'll feel the force.
Okay, sir. And sir, I am having one more question that what is the difference between atmospheric pressure and the gravitational pressure?
Can I answer this?
Udayji, you want to answer this question? Yes.
Yeah. Okay. Gravitational force is acting because at the center, any object is pulling towards it. That means Earth is we are standing on the ground. There is a gravitational force which is pulling you down. As you go up, the gravitational force will keep coming down. But atmospheric pressure is because of the air which is there on in the atmosphere. So at the lowest level, all the air above it is putting a weight on it. Gravitational force will occur even for the planets which does not have atmosphere. But atmospheric pressure will only happen when there is an atmosphere. That is the weight of the air at that particular point. So as you keep going up, the amount of air above it will keep reducing because the amount of air below it is not being counted now. So the weight will keep reducing, and since the weight will keep reducing, the atmospheric pressure will keep reducing.
So, sir, then what is the difference of these 2 points in Venus? Like the gravity of the Venus is 90% of the Earth, but its atmospheric pressure is 92 times of the Earth. So, what does the difference is at this point?
Okay, so gravity is because the center of the universe is center of the Venus is pulling the object towards it. And I don't know what is the gravitational atmospheric pressure of Venus. When he says if it is 90 times, the gravitational force means
probably that is
that is
of
the
the
weight
Earth.
of the atmosphere at that particular point on the surface. This atmospheric pressure is measured at the surface of that particular place. Like to give an example, the atmospheric pressure for average atmospheric pressure is 1013 millibars, hectopascals, sorry, or is around 29.88 millibars, around 29 millibars. Whereas the gravitational force is 9.8 meters per second square. So that is much stronger.
Okay, sir.
That means even certain planets do not have atmosphere. So they, like moon does not have atmosphere, but they will have a gravitational force. Every object will have a gravitational force because it's pulling the object towards it. Atmospheric pressure is just the weight of the atmosphere at that particular point.
And
Weight of
sir,
the air.
I am having one more question. That what is the difference between the gravitational force and the magnetic force?
Okay, so magnetic force, gravitational force is applicable for all the planets, all the heavenly objects, whether it's planets, whatever it is. The magnetic force is because, like planets like Earth, when it was in a molten state, the heavier metals have gone to the core. Because there is iron in the core, it is pulling, it has got a magnetic force. Because of this magnetic force, it creates an electric field which actually reflects all the solar flares. So a lot of solar flares, harmful flares, get reflected because of the magnetic field, which is not the case with other planets. A lot of planets which do not have iron in their core do not have a magnetic field, and because they do not have a magnetic field, the solar flares do not get reflected back by those magnetic fields.
Okay, sir.
Did I
Sir, I
answer
do
your
Okay,
question?
but Saksham, were you asking about the magnetic force of the Earth, or you are asking what is a magnetic force?
No, sir. I was asking the difference between those two forces, like the difference between gravitational and magnetic force.
So, I'll just add to what Udayji has explained to you that how the magnetic field is created inside a Earth. But what is a magnetic force? If someone asks you, it happens. There are the reason is, suppose there is a wire. In the wire there is an electric current. Then there will be a magnetic field. That means moving charges, they produce magnetic field. Whenever the charges move, they produce a magnetic field.
Okay, sir.
Sir, I had one more question.
Yes.
So, sir, I have heard that an magnetic field does not have any poles. So, sir, why is that?
Which magnetic field?
So, sir, any magnetic field of any object does not have any poles. So, sir, why is that?
Magnetic field does not have.
Any
Sorry.
poles?
Sir, can I try to answer this question?
Okay, please go ahead. Today we have our students are very bright, by the way. Yes, please go ahead.
So that's because the poles of the magnet create the magnetic field, and the magnetic field which is being created will not have poles because it will be going everywhere around it.
But the electric field also goes around that object, but it has poles.
No, the electric field does not have any poles. Suppose that if there is a magnet in the electric pole, so that magnet will not have any poles, but it will create the magnetic field around it. It will appear like it has a poles, but it actually does not have any poles.
Uh,
No, Aryan, what is no? When we say poles, what do we mean? We basically, that means if there are the concept of lines of force, they come. That means there is You take a from a magnet, you take another small what you call magnet which has got a north and south pole, and you can draw the lines of force. So lines of force has also a direction, and it goes from north to south.
Yes.
So wherever is the beginning, there is that is the you can tell it as a north pole, and where there is it ends, it's south pole. So what is your question? I didn't get it actually.
So, sir, why does it have no poles? The magnetic field.
No, I'm saying that it has poles.
No, sir, I've heard somewhere that it has no poles. The
Yeah,
magnetic
but
field.
like say the Earth has got a magnetic north pole and magnetic south pole.
Yes, sir.
You cannot have field without those poles. You have to have the both poles to have the field.
Oh, okay.
But basic question, if I don't know whether if you're hinting at that, Arian, is that how
And
the magnetic field is generated. Magnetic field is generated if an electronic a charge, if it moves, it will create a magnetic field around it. It has an electric field and it has a magnetic field also. It creates.
and also
Okay, sir.
we can and
And
also
vice versa, vice versa. A moving magnetic flux can create electric field.
Okay, sir.
So this you may, I think by the time you reach class 11 or 12, you'll be introduced this one. One is that the moving charge produces magnetic field, and the moving flux or flux when it is being cut will produce electric field. So that is why the earlier we used to have electric field and magnetic field being studied separately. But when we learned that one produces the other, then it was made into one single force, electromagnetic force. This was a very interesting development in physics. So electric field produces magnetic field produces electric field.
I guess we are over the time, guys.
sir, I am having one last question that how does our brain creates the magnetic field from 5 nanogauss to 10 nanogauss? It does
Oh,
not have.
is it 10, it is 10 nanogauss, no?
Yes, sir, 5 to 10 nanogauss. So how does it creates the magnetic field even if it does not have any poles?
Now Amarnath's children are asking very difficult questions, by the
Yes,
way.
the kids are ahead of us. I think. How about let's keep it. This is a biomedical science question. We need some uh, bio biophysicists to answer this
Achha,
question.
let me answer whatever I know. Maybe Udayji can add to it. First, you see, how does the earth, let us say, for example, let us leave the brain now. Let us take the heart. How does it pump? The pumping is done by basically electrostatic force, which is generated by the sodium and potassium ions. So that heart as a pump works because of the electric forces. The electric forces causes them to expand and contract and expand and contract. Now in the brain, when you are asking, there are waves are there. Now how they are created, I also don't know, by the way. Maybe I'll try to study it. But yes, you're correct. A little bit of electromagnetic waves are created. But very,
So,
very, very, very feeble it is. Very feeble it is. It is because of this, recently I was hearing to one Baba this one. He said that now even science says that a man can, send waves to another man, the other man will understand what the waves mean and they can communicate without talking to each other. But what is true is that it does produce small waves, and that is what electroencephalogram, which is used, to detect the electric waves and to find out what are the different problems in that. How they are generated in the heart, the mechanism is sodium ions and potassium ions. Means it generates sodium ions, which create electric field, and that is the source of the pressure which is created by the heart. In the brain, what is the mechanism which is followed? I'm not able to answer now. Udayji,
No,
do you
what
have
you are
any answer to this?
no, actually, what you are saying is right. The concept in the brain and heart is similar.
Actually, in the brain also, it is the sodium ion, is it?
Yeah, it's the sodium and potassium ion which actually creates some form of vibration. Now that vibration creates or electrical activity, I'll say. That electrical
It is
activity
electrical
basically
activity.
creates
That
magnetic.
is how in the heart, the charges, they accumulate one place and then disperse, accumulate and disperse, creating electric field, and that is what makes it a pump.
And it is because that particular electrical activity is quite rhythmic. That what is creates oscillation, and it has been used in war actually. What I remember is it was used in Vietnam War also to create it vibrates, I think, at a very low frequency. So if you can create any frequency at that particular which can resonate with the brain frequency, it will have an effect.
Yeah, but her question is a very fundamental question, that how that electric thing comes from where. Now,
So
I'm not
yeah,
sure whether it is sodium or potassium. I do not know
it
about
is
that.
it is movement of sodium and potassium only.
Yeah. Maybe this is an interesting question. Maybe I'll go through it this week and try to answer you next time in more details. Maybe Udayji also can help us. This is a good question, by the way. Thank you very much. So are there some more questions, or we have exceeded the time?
Yes, sir. Now 9:10.
Are there more questions?
No, sir.
Okay, then let's say goodbye to everyone.
Bye bye.
Bye, sir.
Bye.
Yes, sir.
Bye.
Bye bye.